Today, we're going to talk about supercharging a cloud migration with progressive delivery. So the story starts with cloud migration. I've done a lot of cloud migration just because everybody told me, hey, we have to move to public cloud for some reason or another, whether it be data center or another cloud. And it involves 3 steps. The first is refactor the application to cloud. We usually choose a low impact, high value application as a first refactoring step and then eventually replatform other applications over time. The second step is to deploy and test the new application in the cloud. Deploying and testing the new application in the cloud involves a certain amount of time spent debugging, trying to triage any issues. Sometimes it's repackaging the application into a container and replatforming it entirely. The final step is cutting over traffic from one application to the new one. Cutting over traffic seems like a very trivial task, right? A certain percentage of traffic should go from the old one to the new one. As it turns out, it's a lot more complicated than that. The reason why it's more complicated is that it involves me sitting and examining a dashboard. The dashboard usually contains some application metrics, sometimes of errors and of latency. It's important to recognize that this dashboard was created by either myself or someone else, and I didn't necessarily know whether or not the application metrics were accurate. Sometimes I didn't even know if the application metrics were reflecting the same ones from one cloud or data center to another. After examining and questioning my analysis of the application metrics and whether or not there were errors in the application that I've deployed to cloud, I would update the percentage of traffic if I thought it was successful. In this case, I might update the application in the data center to have 75% of all traffic and the application on cloud to have 25% of all traffic. After about a week, I'd reanalyze all the information and see if I could increase the traffic a little bit more. As it turns out, sometimes I couldn't. Sometimes errors only popped up whenever I increased it to about 90% to cloud, in which case I would then roll back and find new things to fix, and then try to repeat the process again. This entire process took months, and it seems like it could take a lot shorter amount of time, except you do want to allow the percent of traffic to bake a bit, right? You need some user requests coming into the applications so that you get a larger sample size and you actually know whether or not the application in cloud is working. Well, who's this person who sat and stared at dashboards and tried to figure out whether or not I could increase canary deployments? Well, my name is Rosemary Wang. I'm a developer advocate at HashiCorp. You can find some of my information as well as some of the other content I generate at this URL there. And you can always reach out to me at JOATMON08. I'm an infrastructure engineer by trade, and I actually enjoy finding the ways that I can automate a lot of these workflows. So when I thought about trying to automate this workflow, I had a wish list of things. The first is that I wanted to automate the increase of traffic and the analysis. It's not to say all analysis should be automated, but I did want to make sure that didn't have to sit there and stare at a dashboard all the time. The second thing I wanted was one source of truth to control. If I have a data center or a first cloud and then a new cloud, I do want to have one source of truth to control both environments. I need to be able to say, okay, here's the DNS of this application, and let me actually control the traffic to both environments. The third thing I wanted was to aggregate and standardize the metrics. Depending on the older environment, I might not have the same kind of metrics that I want in the new environment. If I'm, let's say, replatforming from virtual machines to containers, I might use some of the container metrics libraries out there that actually give me some of the information out of the box. The last thing I wanted was to be able to tag and identify applications on each cloud. This is important from an audit standpoint, and it also is important for me to know which application I was parsing a certain percent of traffic to. So the solution to this, to me, seemed to involve 2 different segments. The first is trying to find some infrastructure layer between multiple environments that abstracts away that control. And that way I get this one view across all of the environments I have. The second solution that I needed was some kind of delivery automation to control and also fix the infrastructure layer. So I needed some delivery automation that would analyze the metrics based on that infrastructure layer and then make the changes and control the percent of traffic. As it turns out, you can do this as long as you supercharge it with a couple of tools out there. You could write your own, but it's pretty difficult. So what are the tools that we have today that allows us to supercharge our cloud migration? The first is the service mesh. Service mesh is an infrastructure layer to manage service-to-service communication. It's a buzzword, but it's actually very useful. It provides really fine-grained control over service-to-service communication, which is really powerful in an environment like this, where you want to be able to parse the certain percentage of traffic to one environment or the other and understand how much traffic you're sending to each. A service mesh works with a few different components. The first is a control plane. This control plane is exactly what it sounds. It passes certain control parameters and configurations, right? So here I'm using Consul as a control plane for my service mesh. Consul has two different clusters. One is in the data center, which is representative of my cloud one. And then I have a second Consul cluster in cloud. That's my second Consul cluster. And what I have to do is pass these configurations to something called proxies. Proxies funnel data between applications. Proxies communicate with each other based on the configuration set by the control plane, which is Consul. In this case, we're using Envoy proxy, but a number of applications and service meshes can use different proxies. So the proxies pass communication to each other, while Consul tells the proxies where this traffic should go. The proxies exist in front of a user interface or application. So the proxies basically process anything between applications. In this case, I have, let's say, a UI application that is a thin client. It can't be moved to the cloud immediately, so I'm going to keep it in the data center. But it references a backend application upstream called my application. The proxies funnel all the requests between UI and my application. I want to migrate my application to cloud. The eventual path is that UI and data center will access my application in cloud. With the proxies in the Consul cluster for cloud communicating across the data center, I can actually apply this infrastructure layer and control the service-to-service communication. So the next solution that you could apply is progressive delivery. Now, progressive delivery is a practice. It's not necessarily a solution per se, but what it's going to offer is control on how and when changes are delivered. Progressive delivery includes practices like canary, feature flagging, and A/B testing, all of which can be implemented and executed by a service mesh. So in this case, combining service mesh and progressive delivery offers a couple benefits. It's agnostic to the data center, cloud, VMs, or containers. In this case today, I'm showing a deployment across VMs and containers. It standardizes the metrics, right? Because the metrics are coming from the proxies. Since the proxies process requests, it's able to provide standardized metrics, and they're fairly uniform across environments. It also offers one layer of control. I can control any of the traffic communication through service mesh. And if I want to implement a progressive delivery model, I'm able to have one point of control through that service mesh. As I mentioned before, it offers the ability to do canary deployments, feature flagging, and A/B testing, agnostic of the application framework. But it has a downside. You have to retrofit the service mesh into older environments. So if you're doing a cloud migration, it's okay to go in and maybe add the service mesh into a newer environment. But in an older environment, you have to take the time and effort to retrofit the service mesh into the applications. And this may or may not be completely possible. I will say it is worth the effort, especially if you do this over 5 or 6 years. Most cloud migrations are running kind of in this hybrid mode or multiple environments for a couple of years. And if you plan on doing that and you have many applications that have to be migrated, you might consider retrofitting the service mesh into an older environment, just so you have the single level of control and you're able to automate and standardize the process of cloud migration and progressively deliver new applications in a new environment. So the setup that I'm going to show today involves a couple components. As I mentioned before, I have a Consul cluster in a data center and a Consul cluster in the cloud. I'm going to migrate my application to the cloud. So here I'm going to configure Consul to funnel traffic between data and cloud. The two Consul clusters are connected through something called federation. They are aware of each other. They actually communicate to each other in order to retrieve the services in each cluster. So, for example, cloud is aware of UI in data center. Because the proxies exist and the service mesh is in place, I can scrape these metrics using Prometheus. Prometheus scrapes metrics from Envoy proxy and collects them. By extension, I can then use Spinnaker and Kayenta Canary analysis to use the metrics from Prometheus and analyze them to do my Canary deployment. I'm only going to show one metric today. You can configure more sophisticated Canary analysis in Kayenta if you want, but today I'm only going to use one metric. When Spinnaker analyzes the metrics and decides that the Canary is successful, it will configure something called a console service splitter. A console service splitter is a configuration entry that determines what percentage of traffic goes to each service. So for example, in the first stage, I'll have Spinnaker deploy 90% of traffic to the data center and send 10% of traffic to the cloud. The console service splitter propagates to the Envoy proxies, and the proxies ultimately control where the traffic will go. For this demonstration, I wanted to expedite the process a bit since it takes some time to run a Canary deployment. Spinnaker itself is using a Canary stage of analysis stage of about 3 minutes each for every increment. So the result is that the pipeline takes about 20 minutes to run. So this has already been executed, which is why I'll just show some of the configuration that's relevant for a Canary deployment and using a service mesh. The first is that I actually configure a console using Spinnaker. In Spinnaker, I'm able to configure console and say I want a service, something called a service resolver. This tells console and subsequently the proxies in the service mesh to resolve anything going to my application cloud, to data center cloud, and service my application. Furthermore, I have a service splitter. The service splitter, as I mentioned before, controls the percent of traffic from one application to the other application. In this case, I have 100% going to my application and 0% going to my application cloud in the first stage. The reason why it's important and why I don't specify specifically my application data center is that by default, the application that is accessing my application will default to its specific console data center. So when I examine console itself, I'll swap to that view. When I examine console itself, I'm able to identify where UI is going to resolve to first. So in the case of the data center, which actually has two views, I have cloud and I have my data center. UI will resolve to my application, and because UI is in data center, it by default goes to the data center my application. However, when I examine my application and the routing configuration, it's actually saying 100% will resolve to cloud now. That's because my pipeline has finished. I've done a successful Canary deployment, so 100% has now been sent to cloud. In terms of the actual configuration itself within Spinnaker to do the Canary configuration runs for about 3 minutes. I'll go to the analysis. Runs for about 3 minutes. I did this to expedite the demonstration, and you can actually set a couple other configurations like delay and interval. I configured a baseline location called data center and Canary location called cloud. This gets passed to my metric in my Canary configuration. The metric will use the location to determine which console data center it should be accessing the metrics from. When I examine the Canary config called Canary, the metric itself includes one metric, which is console's Envoy cluster upstream request. This tracks any requests to an upstream application and records its response code. So in the filter template for Spinnaker, what I'm actually looking for is a console source service. This is a tag added by Envoy and console to the metric. I also have the Envoy response code class. I'm looking for 500 errors in this case. And I also have a console source data center. This source data center is where I'm pulling that data center location. I can specify this or choose a Kubernetes namespace if I wanted to. There are a couple different configurations I can add, but in this case, I'm looking for the console data center that I've set up. When you examine the metrics over time, in this case, I'm using Grafana. When you examine the metrics over time, you can identify where the canary starts to increase for cloud. So I started with most of the traffic going to data center, and over time, it increases the traffic going to my cloud instance of my application. Eventually, this is the 50% point. So the 50% of requests are going to cloud, 50% are going to data center. And eventually now, in this particular setup, I have run 100% going to cloud. I don't delete data center in this particular pipeline because maybe I want to keep data center around for a little while in case there's some regression. It's up to you ultimately and your organization to decide during a successful canary deployment whether or not you'll keep the older application for a little bit longer. So now I'll show a failing canary deployment. The idea is that I have deployed an application to cloud, but it doesn't work. So I'm going to start executing the Spinnaker pipeline. Spinnaker will start by deploying and setting up the canary resolution. So if I examine this within Consul, recall that I mentioned before, it will set a resolver in Consul as well as an initial canary deployment of 10% to cloud. So when I examine UI goes to my application. In my routing, you'll actually notice that 90% goes to data center and 10% goes to cloud. So this starts my canary deployment and everything that goes to my application cloud resolves to the cloud. So notice that Spinnaker flagged the canary analysis as unsuccessful. It will then proceed to a rollback canary stage. This rollback canary stage cuts all the traffic back to data center. So the run canary intervals actually failed the threshold, and the result is that it's actually going to tell me to stop, and it automatically rolls back the canary deployment. So the rollback canary does not delete the canary itself. I might want to keep the canary around for troubleshooting. I can use some of the service mesh capabilities around, let's say, service routing that allows me to check the cloud service using some set of headers, additional layer 7 routing. So I can do a lot of techniques around very similar to A/B testing to determine whether or not the cloud application actually works the way I expect it to without creating another canary deployment again. But the wait basically converts everything back to the data center. And when I examine my Consul service, the routing will then update from 100% to the data center and 0% goes to cloud. Like I said before, I can actually configure something like a router within the service mesh, and that router will allow the interception of traffic based on headers, etc., for further debugging to the canary. More importantly, if I have someone using the application, a customer or otherwise, it will always be available to them because it is routing back to the older application in the data center. So in terms of a cloud migration strategy, the idea is that if you have many applications, all of which depend on each other, you can use this technique to control traffic between all of them. And you don't have to coordinate across 100 different applications and remember which pipelines you have to manually approve to increase the traffic anymore. Instead, you allow something like Spinnaker and the automated canary analysis to handle the analysis portion and automatically increment it for you. And no matter which environment you're in and no matter which target your environment you're in, your pipelines pretty much remain the same. You can use templating in order to configure the service splitters, let's say in Consul, or any kind of traffic management in a service mesh. If you're curious to learn more, I have a list of resources that you can check out. There is a blog that I have about Spinnaker and Consul together. So if you want to know more of the configuration in detail, feel free to check that out. This example is available for your reference as well on GitHub. And if you're interested in canary configurations for Spinnaker, as well as the service splitter entry that I've configured for Consul, I've attached some references here. Don't worry about screenshotting these slides. You can always find them at the URL mon08.github.io. check it out. I'll post these slides on there, and you're always welcome to reference the demo code. If you have any questions, feel free to reach out to me. Thank you, and I appreciate you tuning in to this session. Hi there. I just want to make sure. I think the audio's on. I see it going green. Thanks for tuning in. I appreciate everyone staying around for the presentation. If you have any questions, feel free to drop it in the Q&A. I'll also check the chat as well. One of the commonly asked questions that I get when I was discussing this with a couple folks in the community overall is like, are you able to do this with every service mesh and every kind of deployment in Spinnaker? And the answer is with some caveats. In this case, Spinnaker has a great integration with Kubernetes. So I'm able to use a lot of the Kubernetes constructs to create some of the configuration in the service mesh of my choice. This is also something you can do with any of the other service meshes that you might use, as long as it has some kind of Kubernetes resource and you can leverage that. If you do want to do something to the service mesh API endpoint or use CLI, for example, you will have to use other plugins within Spinnaker in order to do that. That was something that I ran into. I did actually have to set up a CLI plugin at one point just so I could run these same configurations on something that wasn't necessarily a Kubernetes interface. So that's a caveat to that. Otherwise, the other question I get quite a bit is whether or not metrics come out of the box for some of this kind of topology. And the answer is it depends on the tool you're using. Many of the service mesh tooling out there adds some kind of metadata and tagging. So keep in mind that if you're adding some metadata and tagging that's to your tool of choice, your service mesh is likely adding their own tags as well. In this case, I showed tags for, let's say, console source service, console destination service. Those are not universal across all tooling. So the Envoy response code class, for example, that shows the 5, that is more universal because it is using with service meshes that use Envoy. So there are some caveats to some of the configuration here. But if you have any confusion or there's some complications, you're more than welcome to reach out to me. There is a repository that this is associated with. I did link to it in the slides, so you're welcome to review that as well. In terms of the canary analysis, another question that I get is that whether or not you can apply this kind of workflow to anything outside of Spinnaker. And I believe you can take Kayenta and you can inject it into a framework of your choice. There will be some caveats to getting that working. I do know that there is a couple folks in the community who have done that and are able to do that with a service mesh, but they had to separately either create their own kind of canary analysis workflow in their pipelines, or they had to use some other mechanism, so a third-party mechanism. So it is possible to do. However, you have to figure out what kind of investment you want to make. Yes, I will share the link. There is there's also a PDF as well. So here's the link to the PDF of the presentation. I'll share that link in the chat. As for the list of resources, the demo content that at least I showed for this one is under this GitHub. And this GitHub here. And there's also another piece. If you're interested in the exact configurations or at least a deeper explanation of the at the very least, the technicalities, the ins and outs, there is actually a more detailed blog that describes it. The blog itself doesn't show necessarily the cloud migration piece to it. There's some complexities to having two different service meshes in two different in some regions or 2 different data centers. So this blog is just showing the the automated canary deployment piece of it. It is not necessarily showing the multi-cluster component of that. So if you're interested in the multi-cluster component, the code base has the 2 separate clusters and the configurations for how you would federate between the 2 clusters. With that, if there are no more questions, I appreciate those who are still in chat and tuning in. I think I guess we're going to close this feed at least. And if you have any other questions or comments or feedback, you are more than welcome to reach out to me on Twitter or any other social media. Thank you so much and enjoy the rest of CVCon.